morning, students. Up to now, we learned so many topics from the lesson Respiration. In the last class, we discussed about the pathway of air in the process of respiration. Now, today, we will discuss the mechanism of epiglottis. It means epiglottis and passage of air. Epiglottis and passage of air. Already we saw in the process of respiration what are the parts are involved. So that is called the pathway of air. What are they? Nostrils, nasal cavity, pharynx, larynx, trachea, bronchioles, alveolus. Is it right? These all are the parts are involving in the passage of air. Is it right? So here in this topic we will discuss about the main topic that is called epiglottis. Main part, what is that? Epiglottis. So epiglottis and passage of air. So actually the epiglottis, where it is located, already I explained. Epiglottis, where it is located. If you see the pharynx, for example, this is the part pharynx. It means nostrils, nasal cavity after the pharynx. This is the part of pharynx. So, on the top of the pharynx, there is a flap-like structure. There is a flap-like structure that is called epiglottis. That is called epiglottis. This is the flap-like structure. It means వేలాడేటువంటి నిర్మాణము కలిగినటువంటి భాగం. It is a flap-like structure which is located in the part of pharynx. The part of pharynx. So, what is the function of this epiglottis which is located in the pharynx? What is the function? Actually, this epiglottis, it is worked as a traffic constable. Traffic constable. Same work epiglottis will do on the pharynx. What is that? So, when we are taking air, that air, it should enter into the, when we are taking air, it should enter into the windpipe. When we are taking food, that should be entered into the esophagus or food pipe. Esophagus or food pipe. See, it means the air, it should enter into the windpipe. The food, it should enter into the food pipe. Do you know what is pharynx? What is pharynx? The pharynx is the common passage for food and air. It means the food also going that way, the food also going in that way. It means the food and air both are crosses at the way pharynx. It means this part pharynx is the common passage for food and air. So, from this pharynx, the food, it should be entered into the food pipe. From this pharynx, the air, it should be entered into the wind pipe. Okay, the food entered into the food pipe, the air entered into the wind pipe. So, when we are taking air, the air is entered into the windpipe by the direction of epiglottis. When air enters into the esophagus, immediately this flap-like structure, it means the epiglottis is opens. It opens and passes the air into the windpipe. When we are eating food, during that time, the flap-like structure means the epiglottis closes the windpipe. Then the food enters into the food pipe. For example, if the epiglottis is not working in a proper manner, it means when we are taking food, during that time, if the epiglottis is opens, what will happen? The food enters into the windpipe. If the epiglottis is not working properly, immediately when we are eating food, that food is sometimes it may enter into the windpipe. Though during that time, choking will come out. In our words, Paramarindi. Is it right? Sometimes it leads to death also. So that's the reason most of the elders they are saying, while we are eating food, don't talk with others. Is it right? While we are eating, don't talk with others. Because when we are eating food, if the epiglottis is working in a proper manner, otherwise while we are eating, during that time if you are talking with others, this epiglottis it may not work in a proper manner. So that time the food is entered the windpipe. Then choking will come out. So it leads to death also. Sometimes it leads to death also. So here the epiglottis is a good director. It is just like a traffic constable. The food is entered into the food pipe by the direction of epiglottis. The air is entered into the windpipe by the direction of epiglottis. So this is the function of epiglottis. This is the part of, what is that? Pharynx. The pharynx is the common passage for food and air. On the top of the pharynx there is a flap-like structure that is called epiglottis. So if you want to know the function of epiglottis in a practical manner, what we have to do? We will do one small experiment. That is live experiment. What is that? Take your right paw, keep it under the nose, and doing the process of respiration. Is it right? So we feel it. What we feel it? The respiration process is going on. Is it right? So when we keep this right paw under the nose, when we are doing the process of respiration, meanwhile we have to take one apple piece or any other fruit piece and take it into the mouth and chew it. Then when we are chewing and swallowing the fruit piece, before that we have to take our another paw, or this is left paw, keep it under the throat. Keep it on the throat. Okay now. So one paw under the nose, one paw under the throat. So when we are swallowing the fruit piece, what happened? We have to be understand in a clearly manner. When we are swallowing that fruit, immediately we have to stop to take breathing. Is it right or not? How? Because here there is a puff. The gas is not releasing out. When we are swallowing the fruit, immediately we have to be stopped to take respiration. Is it right? Yes. So because of that, when we are swallowing food, we will stop. Means we are not stopping to take breath. What will happen during that time? That epiglottis closes the windpipe, and that fruit piece is sent into the esophagus. See here, the epiglottis, how it is working? It works just like tropic constable. So while we are eating, the epiglottis closes the windpipe and allows the food into the esophagus. Clearly we will understand. So while we are swallowing food, immediately we have to stop to take breathing. Immediately we will not receive any gases from into out. Is it right? So according to that, we will understand while we are swallowing food, we will not take breathing. So that's the reason when we are eating food, don't talk with others.
While breathing, the air moves from the nasal cavity to the pharynx. Here is a tricky situation from the pharynx. There are two passageways, one to the lungs and the other to the stomach. This traffic is maintained properly by a flap-like valve called epiglottis, which protects the tube to the lungs by arresting entry of food. Observe the pictures and discuss the epiglottis and its functioning while breathing or swallowing. This valve closes temporarily when we swallow food and deflects the food down towards the stomach and maintains it out of the trachea or windpipe, which is the route to the lungs. When we breathe air, epiglottis opens more widely and air enters into the lungs. For guiding the function of epiglottis and passage of food and air, nervous regulation is essential.
Okay, next, mechanism of respiration. What is respiration? Inhalation is also called as breathing in, also called as inspiration. Taking oxygen into the lungs, that is called inhalation. Inhalation is also called as breathing in, is also called inspiration. Next, send out carbon dioxide into the outer atmosphere, that is called exhalation. Exhalation is also called breathing out, also called expiration. It means inhalation and exhalation combined together is called respiration. Breathing in, breathe out, or inspiration and expiration is called respiration. Can we able to see the function of our lungs? No. But we can feel it. How? Go to in front of the mirror and taking oxygen into the body. It means when we are doing inhalation, our chest cavity increases. Is it right? We feel it. Something is happening in the lungs, but we can't see the lungs directly. But we feel it. The inhalation process, when we are doing, the chest cavity increases. Then exhalation means breathe out. Then when we come to the normal position, it means the chest cavity is come to the normal position. When we breathe out, the chest cavity is come to the normal position. When we breathe in, automatically the chest cavity is increases. Even though the respiration process we can't see directly, we can feel it. That is possible too. When we are going to in front of the mirror and taking oxygen and releasing carbon dioxide into atmosphere, during that time our chest cavity increases and decreases. That we can see in front of the mirror. That is the power of our lungs. How the lungs inhale and exhale the air. How? The lungs inhale and exhale the air. Lungs alone cannot do the process of inhale and exhale the air. But some of the other organs also participated in the process of inhale and exhale the air. What are they? They are chest wall. The chest wall is made up with rib cage. Rib cage is made up with rib bones, muscles and skin. So these three together is called rib cage. Rib cage is the part in the chest wall. The chest wall is made up with rib bones and muscle and skin. So the chest wall is the main part to participate in the inhale and exhale the air, and also diaphragm is the another part is participated in the process of inhale and exhale the air. So these both are additional parts which is participated in the process of inhale and exhale the air along with lungs. Okay. Now, this is a chest cavity, thoracic cavity or chest wall. This is chest cavity or thoracic cavity or chest wall. Okay. The chest wall is look like a room. For example, this is a chest wall. This is chest wall. It's look like a room. It's look like a room. So below the chest wall, there is another part that is called diaphragm. It is a dome shaped. It is a dome-like shape. Dome-shaped structure. What is that? Diaphragm. It is a rubber sheet. It looks like a rubber sheet. It is in the dome shape. It is in the dome shape. This is a chest wall. The chest wall, it's look like a room. So every room has a floor. Is it right? That floor is here. That is another structure that is called diaphragm. What is that? Diaphragm. So these both are participated. These both parts are participated in the process of inhale and exhale the air. Okay. Alright. See, if you observe the lungs, this is the structure of lungs. This is called trachea. This is called trachea. This is called branches. See, both branches. One is entered into the right and another one is entered into the left. Left lung, right lung. Is it right? Okay. Here, if you observe the mechanism of the inhale and exhale the air, when we are inhale the air, see what I am doing? Inhale the air. The chest cavity increases. When we inhale the air, the chest cavity increases. For example, this is chest cavity. When we are inhale the air, automatically the chest cavity increases. The chest cavity increases. So, when the chest cavity increases in size, inside the lungs, volume also increases. When the chest cavity increases, inside the lungs, volume also increases. So, when the size increases, inside the lungs, air concentration will be less. Inside the air concentration very less compared with outside. Compare with outside air concentration. So here in the lungs, when the chest cavity or lungs expanded, the concentration of the air become less compared with outside. Outside air concentration higher than the inside the lungs concentration. Inside the lungs concentration. Because it's expand. When we are doing inhale, it's expand. So, when the variation takes place, what is the variation? The concentration variation takes place between the lungs and outside the atmosphere. The higher concentration to lower concentration. Here inside the chest cavity or the lungs cavity, there is a lower concentration. So because of this lower concentration, the gases are moving from higher concentration to lower concentration. So automatically the air entered into the lungs. When the air entered into the lungs, when it is increasing size, automatically the diaphragm, before that the diaphragm, it is in the dome shape, but when it is inhalation process takes place, automatically this diaphragm goes down and it becomes flat-like structure. It means the diaphragm contracts and become flat-like structure. When the air comes, when the chest cavity increases, the diaphragm goes down and it becomes flat-like structure. Is it right? Next, when we exhale the air, means we are releasing out carbon dioxide into the atmosphere. Is it right? So now the lungs send out the carbon dioxide. So the diaphragm again it goes up into a normal position. That is called dome shape. Again, this flat-like structure will become normal position. That is called dome-like structure. When it is formed as a dome-like structure, the pressure created inside the lungs, it pushes the lungs. When this diaphragm pushes the lungs, automatically inside the carbon dioxide is sent out into the atmosphere. Do you understand what I am telling? When the diaphragm goes up into a normal position, it means when it is formed as a dome shape, because of this dome shape, this diaphragm pushes the lungs. When the lungs pushes by this diaphragm, automatically the air is sent out into the atmosphere from the lungs. Okay now? Here, this chest cavity and this diaphragm, both parts are participated in the key role for the process of inhalation and exhalation. When the air is entered into the lungs, the process is called inhalation. When the air goes out, that process is called exhalation.
During inspiration, the diaphragm contracts and increases the volume or area of the thoracic cavity. This increase in volume results in a decrease in pressure in the lungs, which causes air to rush from the atmosphere, a higher pressure, into the lungs, a lower pressure. During expiration, the diaphragm returns to a relaxed upward position, reducing the volume or area in the thoracic cavity. Air pressure increases within the lungs at this position, a higher pressure, and forces the air out of the lungs into the atmosphere.
This is a demo video for complete respiration in the 3D diaphragm. Here is a sample animation showing the heart and the movement of the diaphragm. This movement of the diaphragm allows the lungs to change volume, bringing in fresh air and expiring old air. The movement of the diaphragm also displaces and massages the internal organs.
Here, around the lungs, there are two membranes are there. Around the lungs, two membranes are there. These two membranes are called flora. What is that? Flora. So, in between these two membranes, there is a liquid material. This liquid material is called phloratic fluid. What is that? Phloratic fluid. What is the use of this phloratic fluid? So, when we are exposed to some physical shocks, sometimes somebody hit us. Is it right? So, when they hit us, immediately that beating not touches to the lungs, because there is a phloratic fluid. It will give protection to the lungs from the physical shocks. So this is the use of this phloratic fluid. So this layer is called flora. Okay now. Next, if you observe lungs, one is right and another one is left. Right lung and left lung. The right lung always little bit bigger than the left lung. The right lung always bigger than the left lung. Okay. Next, the right lung is divided into three lobes. It means three chambers. The right lung is divided into three chambers or three lobes. Likewise, the left lung is divided into two lobes or two chambers. Okay now? So the right lung is divided into three lobes. The left lung is divided into two lobes. The right lung is bigger than the left lung. Okay now? So this is the additional information. And also one more important point here. In male, rib case is the main role for doing the process of respiration. In male, who is the key role for doing the process of respiration? Rib case. In female, diaphragm is the key role or main participant in the process of inhalation and exhalation process. That is also called respiration. In male, rib case. In female, diaphragm is the main role to participate in the process of respiration. This is the information regarding inhalation and exhalation process. Okay. Thank you.